Okay. So, with motion, that's what we're talking about today. Motion, that's displacement, velocity, acceleration. We kind of already hit on. Okay. Displacement is usually represented as S of t. Velocity is the derivative of displacement, and acceleration is the second derivative of displacement. Okay. Your initial position is when t equals 0. Just like your initial velocity, you will plug in 0 for t into this first derivative, or initial acceleration would be when you plug in 0 for the second derivative for your acceleration. If you say they gave you a particular equation and you had to figure out the velocity, okay, depending at a particular value, at a particular time, right? You would find velocity, you would plug in that time for t, and then if it was less than 0, that meant the object was moving left at that particular time, okay? If it was positive, that means it was moving to the right at that particular time, all right? Now speed, how fast it's going, is always the absolute value of velocity at a particular time, okay? So say you find velocity and it's asking you after 30 seconds. Well, when you plug it in, your speed would be the absolute value of whatever v of 3 would be. Acceleration, okay? If, again, you find acceleration, you plug it in a particular value, if you will be increasing, your velocity will be increasing if acceleration is greater than 0, decreasing if it's less than 0, and if it equals 0, that means it's constant, meaning you're not going fast, you're not going slower, you're just cruising, okay? Exactly. Now, when velocity and acceleration have different signs at a particular value, that means that the object is speeding up. However, if they're different, that means the object is slowing down, okay? So you need to make sure you remember all these things, because depending on what type of question they can ask you, you need to know all these things. You need to know that speed is the absolute value of velocity. Acceleration will tell you if you're increasing or decreasing. Velocity can tell you whether you're moving left or right, so on and so forth, okay? So you just need to make sure you keep everything clear and organized, all right? Let's go ahead and let's get to an example. I am recording this video, so we can kind of hold off on writing what the equation is, what the problem is, and we'll just work it out, because then you guys can go back to the video and write it down and add it to your notes whenever you can. Cool deal? All right. So as the particle moves along the line with displacement function of t over e of t, where s is in meters and t is in seconds, show that v of t equals 1 minus t over e of t. V of t means what? Velocity, which is derivative of displacement. So we basically have to find the first derivative of displacement. What do we have to use to figure that out? Quotient rule, okay?
Or could you bring that to the top and then to the negative? Oh, no, you can't.
That will only work for your monomials.
Yeah, I don't know.
All right, so quotient rule is what? Low. D high. What's the derivative of the high?
1.
Careful. 1. Remember, we're not looking at the velocity equation, we're looking at the displacement. Minus high times the derivative of the low, which is just e to the t, all over low, or low squared. Okay? Now when I simplify this, because I don't know what right now, but when I simplify this, I have e to the t minus t e to the t, all over e to the 2t. And yes, you can take out an e to the t because every single one of these has that in common. Since this is a show problem, we need to actually show that we're taking that out by doing what? Factoring it. So if we take out an e to the t, that leaves us with 1 minus t over e to the 2t. And then those, of course, cancel out to give you just 1 minus t over e to the t. Okay? So then part B says hence, which means therefore, using what you already previously shown, find the particle Define the particular is at rest. Define when the particle is at rest. Define when the particle is at rest. Which means set the derivative equal to 0 or plug in 0. You sure?
Particles at rest is not moving when the velocity is 0.
Speed is time.
Equal to
Find
0.
when the particle
Equal to 0.
Plug in 0.
No,
It's at rest.
Set it equal to
It's at
time
rest.
to the
not
velocity.
necessarily when.
It's at rest, so it's not moving.
Guys, stop thinking about this like POK and think
No,
about
it
it
says
like
find
math.
when.
So the velocity
Find-
function-
No, it says
Yeah,
the velocity function
Equal
is
to.
Alright,
Is
so
that
we
the
are
correct
setting
thing?
this equal.
Is that
This
right?
is wrong. I'm writing it.
Yeah,
You can scratch it out.
Makes less sense.
See, and I think it's also how I wrote it.
So when was it?
If it said write down the value of
So fine, okay, so here we go. We
marvelous.
do this. We
Negative 1.
multiply by e to the t, which means that's gonna go away. So if 1 minus t equals 0,
So t is negative 1.
careful, you have negative
Equals
t
1.
equals a negative 1.
T is 1.
So
Yes,
t
you gotta
equals
watch out for
Well,
the
you can't have
signs.
time negative anyway.
exactly. You cannot have time as negative. So there we go.
That's why it's always good to write out everything, because you will make that
Is
mistake.
that on?
And then you will be sad when you're doing your test corrections and you notice that you missed that point because you got that wrong.
What are you doing?
Here we go. For the displacement function that's given to you with s in meters and t being greater than or equal to 0 seconds, find the speed of the particle at t equals 3 seconds and determine whether the particle is speeding up or slowing down when t equals 3 seconds.
So find the derivative of 3 and absolute value.
So find speed, find the derivative, plug in 3, and then take the absolute value. Because remember, speed is the absolute value of velocity, and velocity is the first derivative of position. So we take the derivative. 6t squared minus 42t plus 6. So then we have to do plug in 3 to figure out exactly what is
What is that?
3 squared is times 6 is 42 times 3 is 126 plus 60. We can do this. We can do this.
That's 6.
So it's basically 114 minus 126 is negative 12. So this is velocity. So we have to take the absolute value to find speed, which is
12. We're going to wrap the value of our AC review.
Yeah.
Like for the odd numbers and even numbers.
Yeah.
Value.
we're talking about that. Okay, so here we go. To determine whether the particle is speeding up or slowing down, you have to look at the signs for velocity and the sign for acceleration. If they're the same, it's speeding up. If they're different, they're slowing down. So we have to now find
The derivative of that.
acceleration, which is the derivative of velocity. So what is the derivative of 6t squared minus 42t plus 6? And we're trying to figure it out at 3 seconds, because that's what it asked us. And so this is going to be a negative, because we have 36 minus 46. So because the signs are the same, we're not looking at speed, we're looking at what velocity was before we took the absolute value. Since the signs are the same, they're speeding up.
Oh, before you take that to the
Before, yeah, because the absolute value was speed. So velocity was negative 12 before we took the absolute value.
So it's going 12 meters per second, and it's speeding up.
Wait, why are we using the speed and acceleration?
Because to determine whether or not we're speeding up when t equals 3, is we gotta look at both of them.
So would they at the same time speeding up and then every time it's slow?
Right. And signs meaning both positive, both negative.
And then B is right before.
So there's the,
For B, it's asking us to find the intervals when the particle is speeding up and slowing down. So finishing up on this particular problem, we've already got through section A, which was finding the speed of the particle at t equals 3 seconds, and then determining whether the particle is speeding up or slowing down. Remember, we look at velocity and acceleration to figure that out. So, to do part B, between 0 and 10 seconds, we're trying to figure out when are we when are we speeding up and when is it slowing down. And remember, we look at velocity and acceleration. If the signs are the same, it is speeding up, and if the signs are different, it's slowing down. So we found that our velocity equation, which was the derivative of the position function, was 6t squared minus 42t plus 60. Okay? And we found that our acceleration formula, which was the derivative of velocity, which is the second derivative of position, is 12t minus 42. Now to figure out the particular time intervals that we need to look at, we need to set both these equations equal to 0. Because if we do, we basically find out when velocity is at rest, and we also find out when acceleration is at rest. And those are some key points that we're trying to figure out if they speed up or slow down. Because at those points, it's not doing it's not doing anything. It's not moving, it's not going left, right, or increasing or decreasing. So we'll set those both equal to 0, and we'll solve for t. This has the greatest common factor of a 6. And now we look for our two numbers that multiply to give us 10, add together to give us a -7, which are -5 and -2. We set both factors equal to 0. And then we won't set the 6 because the 6 equals 0 is just going to be nothing. So t equals 5 and t equals 2. Okay, these are some important numbers that are along our timeline. Now we do the same exact thing for acceleration. Okay? So we're going to add 42 to both sides, divide by 12, and we find out that t equals, so that'd be 42 over 12, which simplifies down to be 7 over 2, which is 3.5. Okay? And so we basically take those and we basically create a number line. Okay? We're going to create a number line for both of these. So 2 and 5. Now realize we're bounded in between 0 and 10, so we want to make sure that we put those values in as well. Alright, so basically what we're going to do now is we're going to pick points that are in between each one of these resting points. So in between 2 and 5 and 0 and 10, and also over there for acceleration. And then we're going to plug them into our, so we're going to pick points and we're going to plug them into the velocity function for this particular number line, and then we're going to pick points and plug them in for the acceleration formula for this number line. We're trying to figure out when the signs are the same and when they're opposite. So if I plug in 1, okay, I end up getting a positive number, a positive 24. This is if I plug in 1. If I plug in 3, I end up getting a negative number. I think it's -12. If I plug in 7, I end up getting a positive 60. So basically, if you recall from this big chart, when velocity is less than 0, the object is moving left, and when velocity is greater than 0, the object is moving right. So we basically know that from 0 to 2, it was moving to the right. From 2 to 5, it turned around and moved to the left. And then from 5 to 10, it turned back around and went back to the right. And then with acceleration, if it's greater than 0, the velocity is increasing, and if it's less than 0, it's decreasing. So for this one, we're going to plug in, let's say 2, and we'll get a -18. And when we plug in 7, we'll get a positive 42. So that means from 0 to -3.5, our velocity is increasing, and then from decreasing, and then from 3.5 to 10, it was increasing. But to answer the question, to figure out where it's speeding up and where it's slowing down, we got to look at the sign changes, okay? So we know that from 0 to 2, and probably the easiest way to do this is to actually line up the number lines. So that's what I'm about to do. I'm gonna go ahead and line up the number lines from 0 to 10. Okay? I'm gonna put acceleration in red. So from here to here, it was a negative. And then from here to here, it was a positive. And velocity, I'm gonna put in pink. Positive, negative, so if we take a look at this, we're at opposite signs from 0 to 2, okay? Since we're at opposite signs from 0 to 2, that means that it is slowing down, okay? So it's slowing down from 0 to 2. Okay? Now the signs are the same from here to here. If we look at how, if we compare and contrast the pink and the red together. So that means if they're the same, that means it's speeding up. So from 2 to 3.5. If we look again, from 3.5 to 5, the signs are different because it was negative here and it was positive here. So that means when the signs are opposite, it's slowing down. And then lastly, if the signs are the same, which they are from here to here, that means it's speeding up. So here are our intervals for where it's speeding up and when it's slowing down. I hope this was helpful. Bring your questions tomorrow to class.